Hello, this is section 4.4. We are zeros of polynomial functions. This time we are looking for the zero of the polynomial. But when they say zero of the polynomial, this is actually the same as x-intercept. Okay, so factor theorem, which is a factor theorem, gives us a really nice zero. So when we use a factor theorem, we need to set equal to zero as a functions. And then we just solving for s, and then x that you find it, that will be the x-intercept, because x-intercept, which is whatever k you plug it in, and then it will becomes 0 as a k and 0, which is x-intercept. All right, so use a graph of the factor theorem to list the factor of f of x. So in here, so we are looking for the list of the factors of f of x. So when they say factors, you put that as a linear factor. Okay, so forms are this form, x minus k. So first of all, we have to find the zeros first. So finding a zero, so 0 is x-intercept, so you have to go to the graphs to which axis this graph going through. So which is -1. And then 1 and 2. So 0 is -1 and 1 and 2. And then if you want to say factors, which means we have to put the x minus k, which is x minus -1, x minus 1, and x minus 2. But 2 negative is not good. So x plus 1, x minus 1, and x minus 1 and x minus 2. Okay, so that's all. And also write the complete factorization, which means we try to get to the factor form, which is if the polynomial is a degree of 2, so we are expecting the 2 zeros, which is we have a 2 0, which is 1/2, and a 4. And also the a we call the leading coefficient. So if you want to get to the complete factorization form, we put the leading coefficient of x minus 0, and then we put the x minus 0 form. Okay, so a is a 7, which is a leading coefficient, and the x minus 1/2 and x minus 4, because those are the zeros already as a given. And second problem, f of x is a 5x cubed minus 5x squared minus 20x plus 20. So we have 3 zeros are given, which is a -2, 1, and 2, as a leading coefficient is going to be the a. So f of x, you don't have to do factoring to find it, okay? So 5 of a of x minus -2 plus 2, right? And the x minus 0, which is 1, x minus 0, which is a 2. So that's all. Very simple to find it. All right, go to the next page. And then number 3, use the graph to graph a function to factor. So instead of the factoring the functions, we have a 0 already here. So there's a 1 0, 2 0, and 3 0. So zeros are from the graph, I think -1 and 1 and 2. And then the a is -1/2. So in order to find the complete factorization form, we get the -1/2 of x minus 0, x minus 0, x minus 0. So that's enough. All right, 0 with a multiplicity. So sometimes when the 0 come out as a more than once, we call that as a multiplicity. So when you have just linear is a degree of 1, that's only that 0 happens once. But sometimes you got a square or a cube, that means that 0 happens to be twice or 3 times. So in here, so 0 with a multiplicity. So when you have x plus 2 square, and then the factor of the x plus 2 occurs twice, and then 0 and -2 is called a 0 of the multiplicity 2. That means there's a -1, which is happens to be 3 times, and then 2 happens to be the 1 times, which is a multiplicity 1. All right, so in here, so where's actually what happened here? So like a -2. So even though it is a quadratic function, but only the 0 you see is a -2, right? But it happens to be twice. So that's actually the 0, -2, and then the multiplicity of 2. And then when you have 0 here, -1 and 2, which is 2 is happens once, and then the -1 actually when you see the graph, it's not straight going through. There's something going on as a -1. So it might be it has to be the Q for this one because it's going through. So when it's going through, usually it is the multiplicities are odd numbers, okay? And then complete the factored form, which is when you have a general form, and then this we call the complete factor form. All right, so let's look at the rational zero test, okay? So when you have a rational zero test, which is when you have a function, the important thing is a sub n and the a here. So if you call the okay, so it's a polynomial function f, the integer coefficient, and then p is a rational number written in the lowest term, and then the p is the 0 of the f, and then p is a factor of the constant term. So when you have a p over q, which is a p is the factor of the constant term by sub 0, and then q is the factor of the leading coefficient, and then you might have a possible rational zero. So, okay, so let's get the possible rational zero for the problem we have. So when we have the polynomial f of x equal to -2x cubed minus 6x squared plus 2x plus 6. So in order to find that one already have a 1, 0 here. Okay, so then in order to find the possible rational zeros is from actually the p over q, but p is from the plus minus factors of a sub 0, and then plus minus factors of a sub n. So in here a sub 0 is 6, so we need to put the factors of 6, and then denominator is the factors of 2. So we don't need really worry about the sign here. So when you get that, when you see that the factors of 6 is actually 1, 2, 3, 6, and then factors of 2 is 1 and 2, okay? And then if you put out as a rational 0, possible rational 0, you need to put that as a ratio, okay? So you can get a 1 over 1, 2 over 1, 3 over 1, and 6 over 1, or 1 over 2, 2 over 2, same as a 1, 3 over 2, 6 over 2 as the same as a 3, okay? So you can get as 1, 2, 3, and 6, and then 1/2, and then 3 over 2 as a plus minus, okay? So this is a possible rational 0. So, but this problem says already 0 is a 1, right? So whatever the zeros you find from this polynomial will be one of those, if that's a rational. So I'm using the synthetics of -2, -6, 2, and 6. There's no missing term, and divide by 1. And then I'm expecting the 0 at the end because remainder should be a 0, and then the number that you use wants to be the zeros. So both are -2, -2, -8, -8, -6, and -6 equal to 0. So I expect that. So this is one of the 0. And then we'll find the more 0, but this is an x cubed and this is an x squared, which means this is a form. So if I set the -2x squared minus 8x minus 6 equal to 0, factor out the -2 squared plus 4x plus 3, and then divide by -2, and then you got x squared plus 4x plus 3, and then this factor as x plus 1 times x plus 3. All right, so you got the actually 2 0 from this quadratic, and then there's a one more 0 here. So if you want to add the factor form, you have to say leading coefficient -2 of x minus 1, 0 from the given, and then x plus 1 and x plus 3. So let's see. Is there a 1 here? Oh, yes, it is, right? Is there a -1 here? Yes, it is. Is there a -3 here? Yes, it is. See that? So everything becomes a rational 0. Also is from the possible rational 0. All right, next problem. So write the complete factor form of the fifth degree of the polynomial f of x shown in the graph. Assume that all zeros are integers, and that the leading coefficient is plus minus 1. So in here, so let's look at the 0 first. So in order to get a 0, I want to say 0 is going to be, this is a 0 and this is a 0. And then the n behavior, right? So one negative, one positive, which means the degree is odd. Could be, but it can be degree of 1 because it's not linear. So it could be degree of 3 or more. And also, so, oh, it says, oh, okay, for the fifth degree. So I know it's a degree of odd, which is a fifth degree here. So 0 is going to be of negative 2 and 1. And then it crossing the x equal to 1, 0, which is an odd multiplicity. But it could be a 1 or a 3, but it can be 1 this time because it's not straight going through the 1. So I want to say 0, 1, multiplicity, 3 instead of 1. And then also 0, negative 2, which is multiplicity. It's going to be the multiplicity, sorry. Multiplicity, which is going to be even because it's a touch, right? So, but this time I want to say 2 or 4. So this graph level is more than 1 that at 0. So approximately I can say that is, okay. So leading coefficient will be negative this time because it's, the right side is down. And then we got the 0 as x plus 2 and x minus 1. So I want to say 0 at the 1 is a multiplicity of 2. And then 0 at the negative 2 is a multiplicity of 2. Okay, so, and then this one actually, and then also the degree. Okay, always same as sum of a multiplicity. Okay, so 1 is a multiplicity of 2, 1 is a multiplicity of 3. Add them up, should be multiplicity of 5, which is that's the fifth degree. Okay, now let's look at the number 6. Okay, so this is actually the finding the rational zeros. I put it on here, okay, to find that. So find all rational zeros of f of x equal to negative 10x cubed minus 17x squared plus 7x plus 2, then the factor f of the x. Alright, so let's find it here. So in here, I can say that the possible rational zeros will be the plus minus factors of a sub 0 over factors of a sub n. So in here, factors of a sub 0 is 2 this time, which is this is a sub 0. And then factors of a sub n is a 10, but you can put negative 10, but we don't really care about sign because the factor will be plus minus sign anyway. So this is actually the a sub n. Now factors of 2 is actually 1 and 2. Factors of 10 is 1, 2, 5, and 10. And then if we put that as a ratio, it becomes 1 over 1, which is 1, 2 over 1, 1 over 2, and 2 over 2 same as 1, and then 1 over 5th, and then 2 fifths, and then 1/10, and then 2/10 same as 1/5. So there will be this is a possible rational zero. So in order to find the zero, so if the zeros are the rational, it will be one of those. Alright, so in order to find the zero, which is I start using the synthetics, so negative 10, negative 17, 7, and 2. Well, but I want to always check with the small number possible. So smallest numbers I can see is a 1/10. But if you, okay, so let's use a 1/10. Let's see what happens. Okay, which is negative 10, and negative 10 is a negative 1, which is negative 18, but negative 18 divided by 10 is not going to be the nice number, which is 10 over an 18 over 10, which is fraction. So we don't want fractions, so we'll stop right here. So start it over. Negative 10, negative 17, 7 and 2. And then this time, I think I want to use the 1/2. And then if I do that, it becomes negative 10, which is negative 5, negative 22, negative 11, and then negative 4 and negative 2. Yes, this is a 0. So 1/2 is one of the 0. And then you can keep doing that. So if you're doing it from here, okay, don't start it over the beginning, okay? And then if you have a 1/5, and then bring down the negative 10, which you multiply to negative 20, which is a 4, 0, see? So which is, we got another one. And then you can stop here doing that, but you can try negative 2. Actually, it works. So negative 10, 20, 0, right? So you found all three zeros. So this is this is a degree of 3, right? So which means zeros are 1/2 and 1 negative 1/5 and negative 2. But this is a degree of 3, so once you have this, right, which is once you have this, you can write that as, from here you can say negative 10x squared minus 22x minus 4 equal to 0. And then when you factor out the negative 2, you get the 5x squared and plus 11x and plus 2, which means you get the 0 from here. So one is a 5x, and then x, and then you need the positive 2, so which everything is a positive, and then you need the 11, so 2, 1 in here, so no 1, 10, yeah. So you can get the 0 from here is negative 1/5 and negative 2. You can get it from here too. So these are the zeros, okay? All right, let's talk about the Descartes rules. Descartes rules of the sign. This is actually the kind of fun to check, but this is a more way to actually define it. So if let the p of x define the polynomial function with a real coefficient and a non-zero constant term with the terms of the descending power of x, and then the number of the positive real zero will be equal to the number of the variation in sign according to the coefficient of the p of x, or less than the number of the positive even integer. And then in order to get a number of the negative real number 0, it could be equal to the number of the variation in sign occurring to the p of, this is a p of x, this is a p of negative x, or less than the number of the variation by the positive even integer. So in number 7, use the Descartes rule to check the sign to determine the possible number of the positive, negative, real 0 this time. So if you want to looking for the number of positive real zeros are, you use exactly same as p of x, but p of x is 3x of 4 plus 2x cubed minus 8x squared minus 10x minus 1. And that we are checking from each term through, we only count that the sign is been vary. Okay, so first and second is not changing, but second and third changing, right? So this is check, and this is not changing, and this is not changing. So in order to find the number of the positive 0, there'll be just a 1. And then in order to find the number of negative real 0, it's not rational, okay? You have to check the p of negative x. So plug in negative x in the x. That's 3 to the negative x to the 4. And 2 times negative x cubed minus 8 times negative x squared minus 10x negative x plus minus 1. So if you simplify, I get in 3x to 4 minus 2x cubed minus 8x squared plus 10x minus 1. So as you notice, only the sign changed from the odd power. So when you take a look, okay, odd power, it was a positive, become negative, and then the negative become positive, okay? And the even power just stays the same. So which means the first one has been changed, second and third not, third and fourth yes, and then fourth and fifth yes. So there'll be the 3, and also you always need to subtract 2 from the whatever number you have. So 3 minus 2 will becomes 1. So it could be 3 or 1 as a negative, okay? If you want to check that out. Alright, so next problem. Factoring can be used to solve the polynomial equation with a degree greater than 2. So find all solutions to each equation. So you can use the factoring, or you can use using the finding the possible rational zero, and also use the Descartes rules. But this one, I think there is a factorable. Okay, so first of all, there is no GCF, but this is actually forms of the quadratic equation. So I think that we can factor in the 2 linear form, because 9 times 12 is going to be 108. And then if you think about the factor from the 108, is going to be, there's a number you can have as 4 times 27, which is a difference of 23, which is this is a work, okay? So I can get that as, I can make that as 9x squared and minus 4, and also x squared plus 3. Okay, and then the 9x squared minus 4 is also factorable still, because it's a difference of 2 squared. But x squared plus 3 is not factorable. Okay, so once you have a factor of factors, complete factorization, and each of the factor, it could be the linear or quadratic, set equal to 0. And then you can just solve for x. So first one is negative 2/3, second 2/3, and third one, subtract negative 3 both sides. It's not going to be a real, because the x squared is negative. But if you put the square root on, negative 3, which is, you got the plus minus I read 3, which is, we got all 4 solutions from the degree of 4. Okay, in B, of course, we need to set one of the sides equal to 0. Subtract 18, and then you get the 3x cubed plus 2x squared minus 27x minus 18 equal to 0. And then we can factor by grouping. So if we have a grouping, so grouping like this, okay? Of course, you have to change the sign of the 18 because you pulled out the negative. And then GCF from the first is the 3x plus 2. 27 and 18 is the 9 is the GCF, which is the 3x plus 2. And then we can do the factor 3x plus 2, and you got the x squared minus 9. And then 9 squared minus 2 factorize out x plus 3 times x minus 3. And then you can just say each of the linear factor equal to 0 to find the solution. So first solution is negative 2/3, second negative 3, fourth is a 3. So you got the 3 solution for this case. Now, we want to think about the intermediate value theorem. Let x sub 1, y sub 1, and y sub x sub 2, y sub 2 with x is 2 different y's, and also x sub 1 is less than x sub 2 be 2 points of the on the graph of the continuous function f. Then on the interval x sub 1, x is between x sub 1 and x sub 2, function assumes that every value between y sub 1 and y sub 2 are the least ones. So intermediate value theorem means, okay, let's say when you have a 1x here and then the y is a value here. So this is one of the point on the graph. And then the other one is actually here, but y is right here, value is right here is a point. So when you connect these 2 points, at least there's a 0. So how'd you get the 0? When you use the 2n number as an interval, if you see the f of 1 and f of 3 are opposite sign, and then we can see that, oh, there might be a zeros. So let's plug it in. So f of 1, 1 cubed minus 1 minus 1, which is a negative 1 less than 0. If you plug it in 3, 3 cubed minus 3 minus 1, which is 27 minus 4, which is 23 is a positive. So as you noticed, f of 1 is the negative 1, f of 3 is a positive 23. So that means there's some x between the 1 and 3 cross will be the x-intercept. So we can just say that there is at least 1, but more than 1 sometimes. 1, 0 between 1 and 3. That's what we call the intermediate value theorem. Alrighty, that's the last. Thank you for listening.